Hello and welcome to this video on identifying the nullity of a matrix. So in this video I'm going to define the nullity of a matrix, and then we're going to go over several examples where I'm given a matrix and then asked to identify the nullity of that matrix. And what we're going to see is that the nullity of a matrix, right, it is the dimension of the null space of a matrix. So finding the nullity of a matrix is also going to be similar to how we found a basis for the null space of a matrix. And I did a video on that a little while back if you'd like to go look that up or watch those again. Alright, so let's get started. I've got the nullity of a matrix. Alright, so the nullity of an m by n matrix A, right? So the nullity of any matrix A is the dimension of the null space of A. To recap, refresh your memory, I'm assuming you've seen this, right? The null space of A is the set of all the solutions of the equation A times some vectors x equals the 0 vector, right? So we're looking for all these vectors x, that make this true, and all those vectors will make up what's called the null space of A. And it was a vector space on its own, right? And also a subspace of Rn, right? If we're talking about an m by n matrix, the null space was a subspace of Euclidean space Rn. All right, and so I've written that out in a little equation with some symbolism here. The nullity of A, right? The nullity of matrix A like this is equal to the dimension of the null space of A. It's this dim of null of A here, the dimension of the null space of A. All right, and one thing we're going to notice, I'm not going to do it in the first few examples, but I will point it out, and then we'll use it as a shortcut in the last few examples. One thing you're going to notice is that the nullity of a matrix A will be the number of non-pivot columns, right? Non-pivot columns of an echelon form of A. So you take the matrix A that you're given, put it into echelon form or reduced echelon form, and the number of non-pivot columns of that matrix will be the nullity of your original matrix. Right? We'll see that happening in the first couple examples. All right, so my first examples, the first 2 or 3 of them here, are going to have these instructions. So I'm given a matrix A, and I'm going to be asked to find the null space of matrix A, right, the null of A, null space of A. Then find a basis for the null space of A. And then once you have a basis, state the nullity of A. And the nullity of A, again, is just the dimension of the null space. So once you have a basis, just how many vectors are in that basis. That's going to be the nullity of A. All right. So if I want to find first part, right, again, and this should look familiar to you. I'm assuming you've seen how to find the null space of a matrix before. So to find the null space of A, right, we're looking at this equation, solutions to this equation. A times, some vector x is equal to the 0 vector. What are solutions to this? Now matrix A, I'll rewrite here, as negative 1, 2, 4, 0. And this is a 2 by 2 matrix, right? So this vector x, this column vector, is going to be a 2 by 1. Have 2 components, say x1 and x2. And we want this to be equal to the, and the 2 by 2 times the 2 by 1 will be the 2 by 1 0 vector. Alright, and then you can set up a system of linear equations that corresponds to this, right? The equations in this system would be, negative x1 plus 2x2 would be equal to 0, and then 4x1 plus 0x2, or just 4x1, would be equal to 0. Right, and set up that system there. Or you could also set up the augmented matrix for the corresponding system, where I have matrix A just written again, right? And these would be the coefficients of x1, and and this 2, 0 column, the coefficients of x2, and you have the equals and then 0, 0 on the other side, right? Now you're going to notice, and you've seen this again if you've been watching videos of mine. You know, I got matrix A over here. When you have a column of zeros on the other side of the equal sign here, you don't really need to write that. You just remember that it's there, because what we're going to be doing is putting these matrices into, you know, echelon form or reduced echelon form, as I prefer. And when you perform row operations, right, a column of zeros will remain a column of zeros. Alright, so all we're going to do really is focus on matrix A, and this column of zeros will stay a column of zeros. And through, you know, row operations, put this into reduced echelon form or reduced row echelon form, RREF, as you've seen, I'm hoping by now. And, you know, I would take 4 times the first row, add it to the second row to make a 0 below this first pivot position. Then multiply the first row by -1 so that the lead non-zero entry is a 1. And then you'd have, you know, you'd have a 8 down here afterwards, and so there would be another pivot position. So, and then there'd be 0. You want to get zeros above that and 1. So you'd see that. Hopefully, you're seeing that matrix A is row equivalent to the identity matrix: 1, 0 for the first column, 0, 1 for the second column. And then again, you'd have these zeros over here on the other side, right? And you know, this matrix in here is the identity matrix. I'll call this, you know, A prime, for, you know, it's A put into some kind of echelon form, and in this case reduced echelon form. And look at A prime here, 1, 0, 0, 1. It's a 2 by, you know, they're 2 by 2 just like you started with. Look at the pivot columns. All right, the pivots are those leading ones, you know, the first ones you're seeing down every row. There's a pivot. Right, pivot position there, second row, there's a pivot position there, and you see how each of these pivot positions is in every column, right? Each column is a pivot column. Meaning that none of the columns are non-pivot columns, right? Kind of sorry about the double negative there, but you know, that means that there aren't any non-pivot columns. All right, and if you recall what I wrote at the bottom of the first page, I said that when we go to find this nullity of A, or the dimension of the null space of A, the nullity will be equivalent to the number of non-pivot columns in echelon form, whether it be echelon form or reduced echelon form. So I'm seeing 0 non-pivot columns. So what we're going to see in a minute here is that the nullity of the matrix is 0. Okay, so now let's get back to the task at hand, you know, finding the null space, the solutions of this equation. Well, if you look at it in reduced echelon form here, this augmented matrix, the first row is telling me that the value of x1 equals 0. Has to be 0. Second row is telling me that the value of x2 has to be 0. So what we're seeing here is that there is only one solution to this equation, this a times x equals 0, and that would be the 0 vector. The only solution is replacing this vector x with the 2 by 1 vector with, you know, just x1 equals 0, x2 equals 0, 0, 0. All right, so there's my null space. My null space, all right, so off to the side here, the null space of A is just the set with, you know, this vector in it, just the 0 vector. And that's it. All right, that is all. And I've come across this in past videos. Again, if you've been watching, if not, don't worry about it. I'm going to talk about it here. This is, you know, the vector space with only the 0 vector in it has an empty basis. There is no basis for a vector, this vector space with only the 0 vector in it. Okay, so the basis for the null space of A is just, you know, the empty set, has no vectors in it, or sometimes it's written as this circle with a slash through it. All right, this is the empty set. Okay. Now you might be thinking, well, wait, what about the set with 0, 0 in it? Isn't that a basis for this? Yeah, that spans this space, right? Every vector in here is a multiple of 0, 0. Because if you take a scalar multiply by 0, 0, you're getting 0, 0 again. But the set with 0, 0 in it, right? Any set with the 0 vector in it is linearly dependent. And you need a basis to have linearly independent vectors, right? So there is no vector. There's no set of vectors that forms a basis for this vector space with just the 0 vector in it. All right, then finally for the nullity then. All right, so then the nullity of matrix A would be the number 0. Right? It's just how many vectors are in a basis for the null space. There are no vectors in this basis for the null space, the empty basis. And as I mentioned earlier, we're going to do a shortcut later with some later examples. The nullity of A is simply how many non-pivot columns are in the echelon forms of A, right? Whether it be echelon form or even reduced echelon form. How many non-pivot columns are there? And here there were no non-pivot columns, right? 0 of them. All right, so I'm seeing the nullity of A is 0. Okay, great. All right, so I'm going to do this again with these same instructions. All right, we'll do a few examples like this, and then I'll just jump to a shortcut, right, where I put the matrix into reduced echelon form, and then look for the number of non-pivot columns. All right, so my second example. Here's matrix A. It's got another 2 by 2. All right, so first I'm trying to find the null space of A. All right, so we're trying to solve, find the solutions of this equation. Matrix A times vector x, some vector equals the 0 vector. So matrix A here is a 2 by 2. So vector x again has to be a 2 by 1, like in the last example, something with 2 components, say x1 and x2. And then this would be the 2 by 1 0 vector, right, with 0, 0. Now, as I set up last time, I mentioned I didn't really need to put that. When we write the augmented matrix for this system, it'll be matrix A on the left, and then you'll have like a bar for where the equal signs go, and then some zeros on the right. Again, I'm just going to say imagine that those are there. Imagine those zeros are there. I'm not going to keep writing them, but just keep imagining that those are there. And we're going to put this matrix A into a reduced echelon form. Now, matrix A is a simple matrix, so putting it into reduced echelon form or reduced row echelon form is really simple. I'm just going to say out loud what I'm doing. Right, I got my pivot position up here, right, first non-zero entry there, and then I would multiply this by 2. I'd multiply the first row by 2 and add it to the second row. And do you see when I do that, the second row would be made up of just a bunch of zeros? Right, 0 here, 0 there, and then to get that pivot position to be a 1, right, the leading here to be a 1, I multiply the top row by -1. Give me 1 here, -2 there. There's reduced echelon form for that matrix. And again, just imagine there's the equals 0 over there. All right, now looking at this, there's a pivot position, right, where this leading 1 is in this first row. Now this is in the row corresponding to coefficients of variable x1, right? So variable x1 is what they call a basic variable. And the second column doesn't have one of these leading ones, doesn't have one of these pivot positions in it. So x2 is going to be a free variable. Right? I can replace x2 with any number I want and then find x1. Well, the columns that correspond to free variables are these non-pivot columns, right? So here's a non-pivot column. Great. And notice there's only one of them, right? There's a pivot column and a non-pivot column. And as we saw with the last example, this, how many non-pivot columns you have is going to be that nullity of the matrix, right? So we'll see later, when I'm done, that the nullity of this matrix is 1. Alright, so now let's go and find the solutions to this equation. What can I replace vector x with? Alright, so as I like to do with my free variables, I'm going to replace it. Now you can leave it as x2 if you wish, but I personally like replacing free variables with other expressions, other parameters that can take on any real number value. So I'm going to replace x2 with, say, the letter t that represents a real number, so t belongs to the real numbers here. Okay. And then from that first row, again, imagine the equal 0 here. From the first row, we're seeing that 1x1 minus 2x2, but again, I'm replacing x2 with t, so minus 2t must be equal to 0, right? The imagined equal 0. And I solve for x1, we get x1 would be equal to 2t then. All right, and now I have each of my variables, right? Each of the unknowns in this equation, x1, x2, in terms of the free variable t. All right, so now I can list all the solutions, or describe all the solutions. I can't list them all, there's infinitely many, but I can describe them. All right, the solutions of this equation, I can replace vector x with a 2 by 1 vector, where the first component, x1, is 2 times whatever I choose for this free variable t. And the second component, x2, is just, whatever I choose for t. And go ahead and try it out. Replace t with any numbers you want. Replace t with 5, replace t with 100, and multiply a by that 2 by 1 vector. You'll get the 0 vector back, I promise you. Now the nice thing is, each of these components has the variable t in common. I pull that free variable out, that scalar out, right? It's a real number, and I'd have t times the vector 2, 1. So what we're seeing in this line is that every solution of this equation, ax equals 0, every solution is just a multiple, a scalar multiple of the vector 2, 1. Okay, so it stands to reason then that the null space of A, right, so the null space of A is equal to the span of the set with the vector 2, 1 in it. Right? Because every single solution of this equation, every vector in the null space is a scalar multiple of 2, 1. Great. And if you did this correctly, right, if you set up your system to matrix so that you have reduced echelon form or just echelon form even, and do this, the pivot columns will correspond to independent vectors, and you'll have set up a nice basis here for your null space if you did everything properly. So this set, right, this set with just the vector 2, 1 in it is a basis for the null space. All right, and let's double check that. Obviously this set spans the space, because every vector in this space we've seen is a scalar multiple of 2, 1, and it is an independent set of vectors, right? There's only one non-zero vector in here, and any set with one non-zero vector is going to be an independent set. Right? So this is a basis, and then looking at this now, this basis for the null space has one vector in it, so the nullity, what they would say is that the nullity of A is 1. Right? Again, this is just how many vectors are in a basis for the null space, or what is the dimension of the null space. That's this nullity. Great. And notice again how the nullity of A was 1, and when I put A into reduced echelon form, or again you could also see it in echelon form, but when I put A into reduced echelon form, there was one non-pivot column, this -2, 0 column here. The nullity will have the same value as the number of non-pivot columns in echelon form or reduced echelon form. Great. All right, so I've got one more example where I'm doing all three of these things, finding the null space, a basis, and the nullity. And then the last several examples, I'll just do a shortcut, right, to find the nullity. All right, so this example here, I've got a 3 by 3 matrix. Right? And again, I'm trying to find first the null space of matrix A. So we're looking at the equation, A times X, when's this equal to the 0 vector? And this is a 3 by 3 matrix, right? So vector X here would have to be a 3 by 1 column vector with components, say, x1, x2, and x3. And we're trying to figure out what these need to be to make this a true statement. Right? All right, so as before, if you were to go through and replace matrix A with what it is, and the 0 vector would be a 3 by 1 column vector with a bunch of 3 zeros in it, and then set up a system of equations and the corresponding augmented matrix for that system, right? You'd have just this matrix on the left, a little bar, and then some zeros on the right. All right, this would be the augmented matrix for that system. I'm going to ignore the zeros. Just imagine they're there. Remember, you're going to have equals 0, equals 0, equals 0 for all these equations. And put this into, reduced echelon form or reduced row echelon form. All right, this time I'm going to have the calculator do it for me. All right. So I have an 84 plus here. Okay, so you go and turn it on. There we go. And then under the matrix menu, second matrix, over to edit. I'm just I'm just doing the 3 by 3. Again, I'm ignoring this column of zeros. You can put it in if you want, make it a 3 by 4, but I'm just going to do matrix A. All right, 3 by 3. I enter the size. Enter the entries. The first row as 1, 3, 2. Second row as -1, 1, 2. Third row has 0, 1, 1. Alright, and then I get out of here, go quit, and then I want to put this in reduced row echelon form, that RREF. Back to the matrix, over to math, scroll until you see RREF. Again, don't confuse this with REF. REF is just row echelon form, which is just echelon form that you're probably used to. We want reduced row echelon form. All right. And again, I really either one's fine, but I like reduced. All right. So then back to the matrix, I want to put matrix A in that reduced row echelon form. Okay, so here it is. So we have 1, 0, 0 for the first column, 0, 1, 0 for the second column, and then -1, 1, 0 for the third column. And again, don't forget you just imagine there's this bar and a bunch of zeros on the other side, equals 0, equals 0, equals 0. All right, looking at this, look at where the pivots are, these leading ones in the rows, right? There's a pivot here and a pivot here, these first non-zero entries in the rows, right? The pivot positions, and that's it. Third row doesn't have a pivot. So look, there are two pivot columns, and one non-pivot column. And that one non-pivot column, or that's going to be the number that's going to be the nullity of our matrix here. The dimension of the null space will be 1. All right, let's go through. So we're seeing these first two columns are pivot columns, so x1 and x2, my variables, right? x1, x2, x3. x1 and x2 are going to be basic. And then the third column is a non-pivot column, so x3 is a free variable. I can let that be any number I wish, and then find x1 and x2. And as I did before, I'm going to replace x3. I'm going to let that be equal to t again, right, where t is any real number. All right, and then I want to solve for x1 and x2. I want to get x1 and x2 in terms of this t. Right, so that's where these rows come in. So the first row tells me that x1, plus no x2, and then minus x3. So minus this t, and again, imagine the equals 0 on the other side. So solving for x1, x1 would simply be t. All right, so whatever I choose to be the value of t, you'll see that the value of x3 and x1 are going to be the same number. Second row, I have x2 plus x3, so plus t equals 0. So x2's value will be the opposite of what I choose for t. And now I have every variable, right, all three of them, in terms of this free variable t. So the solutions of this equation, this ax equals 0, I can replace the vector x with a 3 by 1 column vector, such that that first component x1 is whatever value of t I choose. The second component is the opposite of whatever value of t I choose, and the third component is the value of t I choose, right? And then each one of these has the variable, the scalar, the real number t involved. I can pull that out. T times the vector 1, -1, 1. Okay, so do you see again how every solution of this equation, every solution is a scalar multiple of the vector 1, -1, 1. Alright, so the null space of A is the span of that vector, right? The set with that vector in it. So let me write that out. All right, so that means that, so then the null space of A is the span of the set with just that vector 1, -1, 1 in it. All right, every vector in here, every solution of that equation, ax equals 0, is a multiple, a scalar multiple of that single vector. And, all right, so that's part 1. Part 2, if you did everything correctly in the row echelon form or reduced row echelon form, this set you're getting here, that should be a basis, and we can double check. The set with 1, -1, 1 in it, this set is a basis for the null space. And double check, it obviously spans the space, right? Because every vector in here is a scalar multiple of 1, -1, 1, and it's again a set with only one non-zero vector, and any set with one non-zero vector will be independent. So then the nullity of matrix A, the nullity of A is equal to 1, right? This is the dimension of the null space. How many vectors are in a basis that you're seeing? And I'm only seeing one vector in that basis for the null space. Great. All right, so all those there, those three examples where I was actually finding the null space and then finding a basis for the null space in order to state what the nullity was. But just remember that if you're only asked for the nullity of a matrix, you're just asked for what's the dimension of the null space. So you don't have to find the null space. You don't have to find a basis for the null space. You just have to find a number that tells you how many vectors would be in a basis for a null space if you were to find one. All right, so that's what my last three examples are, and it's very quick and easy. Well, last two examples, sorry, I only got two more. So these last two examples, I'm simply finding the nullity of A, and it's simply going to be the number of non-pivot columns when you put the matrix into an echelon form. So I've got matrix A here, this 3 by 3, and all I'm going to do, I'm going to use the calculator, put this into reduced echelon form. And again, you could do echelon form if you wish to it would give you the same result. Not the same looking matrix, but the same number of non-pivot columns. Right? All right, so back to the calculator here, going to the matrix, over to edit. This is again a 3 by 3, so I keep the same size. I'm just re-entering the entries. Down the first row is 2, -4, 5. Second row, -7, 14, 4, and 3, -6, 1. Alright, and then the last thing I entered on the main screen was reduced row echelon form for matrix A, so I'm just going to re-enter that by hitting second, then enter for this entry thing. And look at this, right? Here it is. There's 1, 0, 0, -2, 0, 0, 0, 1, 0. So there's the matrix reduced to reduced row echelon form. and look for, there's pivots, those non-zero entries in each row. The first one, there's a pivot. The second row has this position as a pivot. So the first and third columns are pivot columns, but I don't care about those right now. When I'm asked for the nullity of A, I'm looking for the non-pivot columns. There is one non-pivot column. So the nullity of this matrix, the dimension of the null space of this matrix, the nullity of A is 1. And I'm done. Right? If that's all I'm asked to find, this is as quick as it gets. All right. Now this doesn't tell me what a basis for the null space is, right? I'd actually have to go through and find the solutions to that AX equals 0 equation. But it tells me that when I go to find a basis for the null space, the basis for the null space that I find better have one vector in it, and only one vector. Alright, so one final example where I'm again asked to just find the nullity of A. So here's matrix A, it's a 3 by 4. Let's put this into reduced echelon form, or reduced row echelon form again. So back to my calculator work. Matrix, again I'm just going to change up A again. So A is a 3 by 4 matrix this time. And then just enter the stuff. First row 3, -2, 16, -2, -1, 5, -14, 18, and then the last row 3, -1, 14, and 2. Alright, then I get out of here, re-enter the reduced row echelon form, and there it is. And so I'll write it out. So got first column 1, 0, 0, second column 0, 1, 0, then 4, -2, 0, and 2, 4, 0. Right. Where are my pivots? Right, the first row, the first non-zero entry is there. Second row, the first non-zero entry is there, and no pivot in the third row. Right. So there are now in this matrix, right, when I reduce it to reduced echelon form, there are now 2 non-pivot columns. Right, so the nullity of this matrix is 2. Again, it doesn't tell me what a basis for the null space is, but it does tell me that if I go to find if I go and actually find the null space and a basis for the null space of this matrix, that any basis I find will have exactly 2 vectors in it. Right. Okay, so hopefully those last 2 examples showed you how very quick and easy it is to find the nullity of a matrix, and and again you saw a nice refresher as to how to find the null space of a matrix, and also a basis for the null space in this video. So there's more of that. And it all boils, it all goes back to those echelon forms, right? And again, I personally like putting things in reduced echelon form, but if you did echelon form, you get the same results, same kinds of results. Yeah, so nothing crazy new here, nothing major, just a new word, nullity, dimension of the null space. All right, so I hope you have fun practicing problems like this, and thank you for watching.